Hello friends, in this video we'll be solving few important questions related to motional EMF rotational cases. Okay, in these all these questions, a rigid body will be rotating about some axis with an angular velocity, and we have to find the potential difference between 2 points on the rigid body. Okay, so let's get started. Find electric field at these points and the potential difference. Okay, first of all, we know electric field is B omega x, where x is the distance from the axis, and its direction is also important. So first of all, choose any point. Let's say C. C is going in upward direction. So if we apply V cross B, B external is up the plane and velocity is this. So V cross B is coming away from the axis. V cross B is coming away from the axis, means axis will have we can say maximum potential, minimum potential. This will be maximum potential, so field will be in this direction, or we can say the field will be, electric field will be like this. Okay, then only V cross B will be balanced by electric field, or we can say QV cross B, magnetic force, will be balanced by electric force. Okay, so electric field in this direction, and at this side of the rod electric field will be in this direction. At all points electric field will be towards the axis, as axis has minimum potential. As you move away from the axis, potential will increase. Okay, so E is B omega x. So what is field at O? E at O is 0, as O is the axis itself. Field at P, P is here, so the field is nothing but B omega L I cap. Field at C is B omega L, but it will be minus I cap because the field is towards the axis. Field at Q is B omega 2L and also minus I cap, because again it is towards the axis. Now we have to find the potential difference. We know that the potential difference delta V mod is simply B omega by 2 x1 square minus x2 square, and we give sign as per which is larger or which is smaller. So let's start with the first one, Vp minus Vo. Vp minus Vo. P is at a distance L, O is the axis, so the value will be B omega by 2 L square minus 0 square, and whether it will be positive or negative, as we know that V cross B is away from the axis, so axis will be at minimum potential. Okay, axis will be at minimum potential, so P will have greater potential as compared to this, so the difference will be positive. Similarly, part B will be VO minus VC. O is the minimum potential, so the term obviously will come out to be negative, and B omega by 2, and find the difference L square minus 0 square. The C part is VP minus VC. Okay, B omega by 2 and P and C. P and C both are L distance, so this will be 0. If points are equidistant from the axis, potential difference will be 0. And Vp minus Vc, again P is I have already calculated Vp minus Vc. Last one is Vq minus Vp. Vq minus Vp is last one. So what about Vq? Q is at a distance 2L, so its potential will be more. Away from the axis, potential increases in this case, so more minus less will be positive. B omega by 2 and 2L square, this distance is 3L. 3L square minus L square, so it will be 8, means 4 B omega L square. Okay, Okay, so you must be able to solve these kind of questions after solving so many examples. Okay. In the next question, there is a disk rotating with angular velocity omega in uniform magnetic field. First of all, specify whether center is at highest or lowest potential. As we know, let's take the velocity of any general point. Let P has a velocity in this direction, and magnetic field is out of the plane, into the plane of paper. So V cross B is towards right, means electric field, or we can say V cross B at P is towards right, means towards the axis. So axis has maximum potential in this diagram. As we move away from the axis, the potential will decrease. So Vs minus Vo will be obviously negative. Axis has minimum potential, so it will be V omega r square minus 0 square by 2. Negative sign because the term will come out to be negative. Smaller potential, larger potential. Vo minus Vp. P is the midpoint of OS, so it will be positive. Axis has maximum potential, B omega by 2. We get r square minus r by 2 ka square. So we get nothing but how much? This will be 3 B omega r square by 8. Okay. And in the last example, a rigid frame is rotating with uniform magnetic field. Find Vo minus Vp, and let's take velocity of any general point P. P has a velocity in this direction, in upward direction, because angular velocity is anti-clockwise, and magnetic field is out of the plane. So V cross B is coming in this direction once again. So V cross B is this, that is away from the axis. This arrow at P is away from the axis. So axis has minimum potential. First observation is VO is minimum. Okay. So VO minus VP first of all will be negative. The distance from O to P is, this is B omega, and distance is 8 square by 2, and the other term will be 0 because O is the axis, and VQ minus VO is B omega by 2. The term will be obviously, we can say positive. This term should be negative, and this will be VQ minus VO will be positive, and Q is having a distance. You can easily calculate this distance. This is 3 and 3 6, 8, 90 degree angle, so this distance will come out to be 10. Okay, we have to just find the distance of Q from axis. So 10 square minus 0 square, that will be 50 B omega, and last one is VQ minus VP. Again Q is at a larger distance, so potential will be more. As axis has minimum potential and we move away from the axis, potential increases. So VQ minus VP. VQ is B omega by 2. Distance is 10 square minus 8 square, and it will be positive because VQ is greater than VP. That will give you 100 minus 64 is 36 by 2. It will be, so that will be 36 by 2, 18 B omega. So this is how we can find the potential difference between any 2 points on a rigid body which is rotating in magnetic field. Enjoy.